We're ready to get started. So welcome everyone. I'm David Habood. Today, Alexander Tamari is joining me to help with questions and answers. He will be helping initiate some polling questions later today as well. If you have any questions, please put them in the question and answer section and not in the chat section. If you have any, if there's any issues such as you can't see something, put it in the chat section. That way we can see it a little bit easier. But if you want us to respond, the question and answer section is a better alternative for that. So today we're going to discuss some of the features in Altium Designer 20 that are a little bit more difficult to discover on your own. So if you have seen my last webinar on the key features of Altium Designer 20, you've seen a lot of the changes we have made, specifically, the changes to routing over that have been a long-term investment over the last 5 years. But there are a lot of little things that you wouldn't normally find without some guidance. So today we're going to talk a little bit about that. We're going to start off with our first poll today about efficiency. So Alex. So we're going to go into our first topic here. The view configuration. In Altium Designer 20, you are able to now add permanent layers. This is going to help you when you have, for example, a reference layer that you need to constantly be addressing. Let's say you're on your top layer and you need to address a reference layer down in your design, right? You can make that a permanent layer, go down in single layer mode, and actually make changes in your design while still being able to see that layer. Coming down through, when you have unused pads and vias in your design, previously you had to both remove the unused vias, and then later when you needed to restore them, those were two separate items, right? So people were going back and forth. You would have to go in there. You would have to go to the tool section, remove them. Now you are able to both update pads that are in use and remove the ones that are no longer in use. And that all happens in one move. As well, we have added a new scope, which allows you to look at both the vias and pads. This is something that's a huge improvement as well. We've been working with Symbior over the last couple of years with the simulation of impedance. Now you can do asymmetric strip-line impedance calculations. This is a really cool addition. On the 30th of this month in January, Vince Mazer will have a full webinar solely dedicated to impedance calculation of transmission lines. So if you are more interested in that, I highly recommend you go to that webinar. But for now, we're just talking here specifically about asymmetric strip-line impedance. This is something that's unique to Altium Designer, being able to calculate with different dielectric thicknesses, and it's something that you could only do in Altium Designer. And you could see that you could do it for both single differential and both single and differential coplanar calculations as well. The next thing we're going to talk about, we talked a little bit in the webinar invitation about improving your documentation. So throughout the years, you've been able to create device sheets, and you've been able to create ports in hierarchical designs and navigate through them while you're inside Altium Designer. So we wanted to add this ability within an output itself. So now when you create a smart PDF, you're actually able to click through the sheet entries and the symbols and the ports to navigate through the design. And you can see here in this simple picture, we're going to navigate through one later, but you can click through and navigate from one sheet entry through into the necessary schematic. this is a really great improvement that I'm pretty excited about. When you need just Altium Designer to view files, previously you had to go get a viewer license. You would have to get it updated every 6 months. It was a whole process. You usually had a separate installation. You no longer have to do any of that. If you have your Altium Live credentials, all you need to do is have Altium Live. You sign in from your regular Altium Designer installation, and it automatically recognizes that you're not using an active license, and you can acquire an Altium Designer viewer license. So let's say you do not have an Altium Live account already. You just have a license file. You would talk to your admin for your company, your organization. They would create some Altium Live credentials for you, and then you would be able to sign in and get a viewer license for yourself. And there are a lot of added benefits to having Altium Live credentials. You could go on the forums and communicate with the community and learn more through there. I see some questions already coming in the Q&A. That's good. Okay, so from here we're going to talk about calculating polygon pore area. So when you have a polygon, it's really important to optimize the overall balance of your copper across any layer, right? So now that you're able to see the precise area of your design, you're also able to generate a report of it. Once you have the report, you see the percentage of the copper pore over the whole design itself. On top of this, it's also important to see the area of your components in relation to your overall board. So now in the properties panel, when you're looking at your PCB itself, you're able to see the entire board area and the component area of each individual item. When you are looking at a component itself, if you are using the component layer type, right, and we'll go over that in a little bit. In the demonstration, I will show you how to make a component layer if you don't already know how to make that. But it will take the area of the component layer and it will calculate that in your design. And with that, it will take the board area, it will double that board area and take the relationship of the component area and give you the board component density. And based on that density, you see if you can have a single layer board, if you have a high density board, you can know a little bit more information about your board. And you see here, this design is pretty dense. It's got 37% density, the mini PC design right here. And that's a reference design that is included with Altium Designer 20. So you can open it up yourself and check it out. So this is another unique situation that a lot of people run across. When you have a component with a unique footprint, once again, the Courtyard comes into play here. In Altium Designer 19, the Courtyard here of the boundary of these two components when selected would create a DRC error, right? Because they would, in theory, be touching. In Altium Designer 20, we have improved how the component boundary is created. It no longer goes to the greatest area of the component. So it makes a better dynamic shape around the component selection. And if you have accurately defined a courtyard, as you see in the last picture, it will take the shape of the courtyard and give you the most accurate shape for selection. Simple net assignment. So when you have a copper pore, for example, it could be really difficult to assign a net to it. If you have hundreds of different nets, thousands of different nets, scrolling through all those nets to find the appropriate net can be an extreme challenge. So to make that really simple, what we've done is add a simple click button. You click it and you go onto your board and you can see the little crosshair. It's a little difficult to see, but it's green, and you simply click on the net and it assigns that net to the copper region. And this will work for any net primitive. So if you need to change the net of any item on your board, it will work. But in this example, we're working with a polygon port because it's really easy to see. If you saw my previous webinar on Altium Designer 20, you see that in the properties panel, we have improved the polygon actions. In the properties panel, you can see at the top right corner, there are things such as the repour, the shelve, and different actions, right, in regards to the polygon itself. So this is another change that people have been requesting for a long time. We have made slight modifications over the years to this, but now you can do this in both alignment and justification, right? So you can do left, center, right, and you can do top, middle, bottom for this type of, for all types of strings. This will get you perfect alignment of all strings, and you can, we'll see a little bit later, the alignment of some designators and how easy it is to perfectly align your text for some documentation. And this is what I was mentioning. So we wanted to make documentation easier, as we talked about. So we have added the ability to add a designator layer for assembly drawings within your PCB. You can do tool, add designators, and it will place this in the geometric center of your components. So you could also do this in a PCB library, and it will apply to all component footprints, right? So if you're in the PCB library, it will just apply to that. If you're in the board, it will apply to all components on the board itself. So from here, I'm going to switch over to Altium Designer. Okay, can everyone see Altium Designer? Just raise your hand real quick, pop it up and down. Okay, I see it. Okay, so we're going to start off with the first area. We talked about the viewer license. So I'm here in the license management option. You could see I am currently using a valid license, but I have down here a get viewer license option. So I'm going to click get viewer license, and it says, actually, to make it even more, I'm going to release, right? And I'm going to do create license. And you see here, now I have a valid user license that I can, a valid viewer license that I can use. And that's just for me to use at any time. And I can now use my installation whenever I need to, right? So if you have a limitation on the number of licenses you have, and sometimes you just need to view some files, you can use your regular installation and just use your viewer license when need be, and then switch over whenever you need to use your active license. So there you go. And I switched over to my viewer license. Coming over to an actual design, we see the mini PC project. We talked about the smart PDF. So you go to File, Smart PDF, and a wizard will come through to actually generate this smart PDF. We're not going to run through it right now. We're just going to let it go through. And it looks like I had the PDF open earlier, but it looks like it closed on me in my preparation. So I'm going to open it up on the side here. And as I mentioned earlier, we wanted to be able to navigate through, right? So when you are in the design itself, you can use the ports you can do control click, and you could click on a port and it will bring you to another schematic sheet over here. And you can do that through, so this is a port itself, and the ports will bring you through to each other. You can do sheet entries, right? These are sheet entries, and they will allow you to come through. So this is a port on this side, right? And when I come through the other side, it's a sheet entry. Or I can click on the sheet itself, and it will allow me to come through and open that up. So is this, I'm looking over here to try and open the PDF. Okay, so you see the simple navigation there, and we want to recreate that over here. Seems I click the PDF, but it doesn't seem to be opening. It opened behind my Zoom screen, so I couldn't see it. That makes sense. My apologies. And then I have to do new share. Okay. Here we go. So here we have the full design. We have some people raising their hands. Can you all see the PDF? Has stopped as the share window is closed. Interesting. Okay. Give me 1 second. Okay, let's see if I share mini PC PDF. Is that good? Okay, perfect. So here we have it. As I mentioned, we wanted to be able to give you this visibility in an output. So now we have the same type of navigation here with the same type of speed. So we're going to go back to Altium Designer and switch over now to the PCB document. So we're going to start off by adding the designated layer assembly for the assembly drawings. So when I went here, I'm going to do that a little bit slower. So I go to Tools, Add Designators for Assembly Drawing. And it says, I'm not showing it again, right? See hands. Good. This is working. Resume sharing. Let's see. New share. Okay. That's good. You guys are responsive. That means you're paying attention. Okay. Everyone see the screen? Yes. Okay. Perfect. So, mini PC. We have it up. We come over to Tools. Add Designators for Assembly Drawing. And it shows us here that we have no mechanical layer for these assembly drawings. So it asked me, would I like to add the mechanical layer? So yes, I would. And it will build out this new layer for us, and it will add the designator on this layer. But what you will notice here is it's a little bit large. A lot of these designators, I don't want them quite this large. So I'm going to select one of them and right click, find similar objects. And I will do same type and click apply just so you can see it work. right? So it selected all of the same. So I click the right thing. This mic's like right in my face. I'm not totally sure what just happened. Okay, let's go back. So I click on one of these, find similar objects. That's the wrong one, isn't it? There we go. I was clicking on the wrong one, sorry. Okay, find similar objects. Same, okay. And it selects all of them. And 1.5 millimeters is a little bit large for me, so I'm just going to do 0.5. And you see how much smaller that they have gotten. I switched to single layer mode, and you see the size difference here. From here, I'm going to introduce the justification. So I simply go to one of these types of fonts, and I want to make sure that it's right in the center. So I do a center, and we can see that all of these designators are now being centered exactly where I need them to be. And you can see how easy that was to add all of these designators for all of these components. And now I can quickly document this. Okay. Now we're going to come over here, and we're going to place two components. I'm going to do it on the side here, since this is a pretty dense board, just to show this rather quickly. So if we have these two together, technically right here, we would have a DRC error, right? What I'm going to do now is I'm going to right click in the components panel and edit this. What I can do now is go into the component. I'm going to switch this from the top overlay layer, and coming back into the view configuration, you can see here the component layers pair, right? That's one of the type of layer types. So you add a component layer pair, and you add a courtyard. So once you add a courtyard, you can select this top overlay, and I can move it over to the top courtyard. So it's important not to define both a top and bottom courtyard because it will interfere with each other. If it's supposed to be a top mounted component, usually put a top courtyard. If it's supposed to be bottom, do bottom. You shouldn't be defining both courtyards. It's something that a lot of people make mistakes with initially. So now that I have updated that, I can save it, and I do tools, update PCB with current footprint. And when I switch back, that top courtyard, interesting. So this is the top courtyard. To do update PCB with current footprint. Okay, yeah. So here you go. You see here when I click on the component itself, now it is selecting them with courtyards, and we would no longer have DRC errors. And you could see how that is perfectly selected. So if you have a component with a very unique shape, you simply define the courtyard perfectly as need be, and you can make sure that you don't have any issues. From there, I want to highlight that in the properties panel, you could actually see the component area, right? And that is defined from the area of the courtyard. So if I undo the changes, you see that it now uses the area of the boundary. So it's really important to be specific and to use the courtyard system to get the most accurate representation of your board density and understand a little bit more about your design in general. If you don't want to use that item in your design for board density, all you have to do is put 0, and it will no longer calculate that into the overall design. For example, you know, if you have like this design has a big heat sink in the middle. If we wanted to not take into account the area of this fan, we could make that 0, and it will change, right, the board density of this whole design. So looking at just the board by itself, without anything selected, you get the full information of the board. You get the area of the board and the component area. So the component area is including the top and bottom layer, while the board area is just, you know, the board outline area. So when it takes account into the density, it's going to take into account twice the area divided by the components area. So that then you will get the density. Otherwise, you wouldn't be able to do that since there's a top and bottom side. From here, we're going to look at the polygon pores. So you go Tools, Polygon Pores, Polygon Manager. And so here. So when you have all of these polygons, you can see them here. I'm going to unshelve these polygons. Right. Apply. And you saw initially the right now it's going to pour all those polygons down, and we're going to get a accurate representation of the polygon area once it is poured. Right. And you can click on them, see more information about them. and from here, if we want to get a report, I can go to Reports, Board Information, or from the Properties panel, I can click Reports. So here I can see board specifications. I'm going to do a report on copper area. And it will create a simple report, HTML, where it will show me each layer, and it will show me the area and the percentage of layer that is copper, right? So you could see here, and you could get a little bit more information on your board itself. So coming back down, I'm actually going to shelve these. We're coming here to a via. This via has pads all the way down through, right? So in order to fully optimize copper pores throughout my design, and I don't want them to be perforated by random pads that are unnecessary, I would use the tools remove unused pad shapes feature, right? Like I mentioned before, I would have to remove them, and then if I needed to use them later, I'd have to restore unused and go back and forth. Now you're able to use the update unused feature. So I'm going to use it here, and you could see it updated all of them at once. It removed the ones that were unnecessary, and you could see in my pad stack for this via, or my via stack, it just removed the ones that are unnecessary while retaining the ones that were necessary. It kept the shape, it kept everything that was necessary. And if I remove something here and perform the same operation, I would get the same benefit as well. If I come over here now, I'm going to pour a very simple region here. You can see right there, right? But right now it's not actually assigned to anything. So when I click on the region on the pour, I can click the single net assignment, and I can actually click on ground, and I can say re-pour, and it will re-pour it as needed for me right here. Coming over to the view configuration section, I have made a predefined layer set for my ground layers. And I need to reference this plane right here. You know, I need to reference this little area, this pour right here. Let's assume it was a much greater area, and I had made a whole ground plane over here. So I am gonna go into single layer mode, right? And you can see I'm actually in single layer mode for the top layer, but I can change the visibility of different items. So let me go back here, Polygon pour. So we can see the different regions in play while we are working with the different layers. So the last thing I wanted to show was the layer stack. Okay, so we are in the layer stack. We are in the impedance profile section. Okay. Once you're in the impedance profile section, you are able to define an impedance profile and define right here the different references between the different layers. And you can see here I have different materials in between the layers. So if I actually click on the top layer, this simulation area, I think earlier it said something changed and I said no, and I think I need to update it. Give me 1 second, let me update this. When you have these different regions, in this area, there is the simulation with the Symbior engine. So this is where we work with the company Symbian for our impedance calculation. As I mentioned earlier, I'm just going to close this. There are different methods we have for impedance calculations. You can do impedance calculations for single and differential lines. You can do impedance calculation also for coplanar reference planes. And let me just open up the layer stack manager again. I see we have some more questions over here in the Q&A. And as I mentioned, Alex will be assisting a little bit over here. I see some questions in the chat area as well. Okay. So I switch impedance profile. And for some reason, this is not showing up on my screen. Very interesting. Well, the graphic isn't showing up, but you can see here you have all of the simulation information. The graphic is just showing you the I showed it in the picture earlier, the top level plus the thicknesses of the dielectrics. But you can see here you have the width of the trace, W1 and W2, and you have the impedance, deviation, delay, inductance, and capacitance. The fact that it's asymmetric is very unique to Altium Designer. You can have different dielectric constants, which is also unique, and different thicknesses, which if you tried that, in Altium Designer 19, you can put two different layers that were the same dielectric constant, and it would just basically assume it was one thick layer. But now you can put different materials, different thicknesses, and different dielectric constants, which really helps you with the overall simulation, and it allows you to do things that you can't do in other tools. So from there, I'm going to switch back to the PowerPoint. Altium Designer is available now. If you're on subscription, all you have to do is install it, get the download at altium.com/downloads. The release notes are available on our documentation page. So go ahead and get that. You can learn a little bit more about some of these features. If you have any questions, now we're going to open it up.